Let's talk about homogeneous systems of equations. A system of equations like x plus y plus z equals 0, 2x minus y plus z equals 0, 2y minus z equals 0, where the constant term is 0, is a homogeneous system of equations. One obvious solution is when all the variables are 0. X equals 0, y equals 0, z equals 0. This is the trivial solution. Sometimes this system will have another solution, a non-trivial solution. For example, the homogeneous system x minus 3y equals 0, negative 2x plus 6y equals 0, of course, has the trivial solution, but it also has a non-trivial solution. 3, 1 is a non-trivial solution. You can plug that in and find out for yourself. There are others. Find all solutions to the homogeneous system of equations x plus 2y plus 4z equals 0, 2x plus y plus 5z equals 0, y plus z equals 0. So first, we represent this as an augmented matrix. Let's get it in reduced row echelon form. First, let's kill off this 2 underneath the 1. Okay, we know how to do that. You multiply the top row by negative 1, and then blah, blah, blah. You do all of that. So after you get in reduced row echelon form, this is what you end up with. Now, let's convert that back to a system of equations. This is x plus 2z equals 0, and this is y plus z equals 0. So let's get those leading variables on the left side. The leading variables are the variables that have a leading 1, columns that have a leading 1. So x equals negative 2z, y equals negative z. Z is a free variable. The z column doesn't have a leading variable in it. Okay, so x equals negative 2z, y equals negative z. Z is a free variable. This is our general solution. Z can be anything. For example, if z equals 3, we get, okay, let's plug in z equals 3 into this. We're going to get x equals negative 2 times 3, which is x equals negative 6. We're going to get y equals negative 3, which is y equals negative 3, and of course z equals 3. Okay, so yeah, that would be a solution. Negative 6, negative 3, 3. There are infinitely many solutions. If a homogeneous linear system of equations has n variables, and the row echelon form of the augmented matrix has r non-zero rows, then the system has r leading variables and n minus r free variables. For example, in the above system, there were n equals 3 variables because we had x, y, and z. R equals 2 non-zero rows. We just had the 2 non-zero rows. So the system has r equals 2 leading variables and n minus r equals 1 free variable. Why? Well, each non-zero row has a leading 1 in it, which corresponds to a leading variable. So in this case, x and y are leading variables. Variables are either free or leading. If there are n variables and r of them are leading variables, then the other n minus r variables must be free variables. So if these are leading variables, then everything else, in this case z, has to be a free variable.